Okay, we're going to talk about Python, machine language, and geospatial. We've got a couple exercises here. First exercise, which is going to be on map generation and geospatial analysis. And a second exercise is going to be on real estate. Simply put, real estate. This is a geospatial analysis, but we're going to be using a real estate database in Miami, South Florida. So let's get it started. An introduction to geospatial visualization. What is geospatial data? What does geospatial mean? Okay, well, geospatial data is time-based data that is related to a specific location on the Earth's surface. It can provide insights into relationships between variables and reveal patterns and trends. Okay. So for our file formats, let's take a look at the data. We've got shape files, we have database files. These are more like shapefile indexes. This particular one is a keyhole markup language. And a keyhole markup language is some of you folks that use Google might be familiar with this, but it stands for keyhole, of course, KML stands for keyhole markup language. There's also a KMZ, which is a zipped version of that. And it's a GIS format, which is XML based and is primarily used on Google Earth, okay? Which is pretty cool because if you have those files, you could just drop into a Google Earth and it will automatically project that data set, that spatial data set on your Google Earth, which makes it very, very simple to use. Additionally, there is a IMG file, IMG format, which is a proprietary format developed by the Hexagon Geospatial. Some folks might be familiar with proprietary image or GIS, image processing and GIS analytical software. These are NVDI, ERDAS, plus there are others out there as well. Last one I'm going to talk about is TIFF, which a TIFF, if you add any spatial information to a TIFF file, it becomes a GeoTIFF. And it is a very popular file in GIS and satellite remote sensing applications. It's rasterized format. It's a raster format, meaning that each pixel is a data set or within a data frame. And just out of, if you want to get a strong understanding on that, I would tell you to look up. I would tell you to look up this here. Let me share with you. You can take a look at Planet Labs. Planet Labs is one of the companies that has a massive mission on incorporating and fusing geospatial information with a variety of data sets which allow for the interpretation and determination of changes that are very dynamic databases, very dynamic image data sets, which have the ability to monitor climate change. It's used heavily in logistics. It's used in many different ways. It's a discussion by itself. And if there's interest, I'll be happy to talk about that further. And we'll get back to that a little later on anyway. So once again, we already covered this part here. We just did a search on that. So how is geospatial data used? How can it be used? Well, the ways that geospatial data can be used is, in our case, where should a global nonprofit expand its reach in remote areas of the Philippines? Another example, how do purple martins, which is a bird species that's being monitored because its volumes are, its occurrences are decreasing, so there are people who are studying them. So how do purple martins, a threatened bird species, travel between North and South America? Are those birds traveling to conservation areas, right? Also, another one, Which areas of Japan could potentially benefit from extra earthquake reinforcement? Okay, not benefit from earthquakes, but benefit from earthquake reinforcement. So which areas of Japan could potentially do that? And you would basically have maps with earthquake activity, measured earthquake activity on those maps to illustrate what areas have more seismic activity than others. Here's another one. Which Starbucks stores in California are strong candidates for the next Starbucks Reserve Roastery location? So in the context of commercial space, you would look at demand and lack of locations to say, oh, well, we can put a Starbucks over there, or we can put a Starbucks over there, or we can close that one down because it doesn't get enough business. This could be done in any kind of retail, commercial category. So it does not matter. You know, Starbucks is just an example. And no, they're not sponsoring this video. Another one. Does New York City have sufficient hospitals to respond to motor vehicle collisions? Which areas of the city have gaps in coverage? Okay, see how powerful this can be? Geospatial is a very powerful tool. Next one. Well, how will we going to use geospatial data in this lecture? Okay, because this is a very short, simplified lecture for my ENV class at Florida Memorial. And I just wanted to give the students a taste of this because, you know, even though we're doing a very core course in science, it's very important to understand that what you learn can be applied in just about any industry. And these are the things that I tried to pass on to my students, that, yeah, we're learning about very basic science and very basic methods, but look how they can be applied. And it can be applied in any industry that you are going into, and it will benefit any industry that you're in. So you're going to be, you're actually going to perform a leg up by understanding these numerical and physical relationships. Okay, moving forward. So we're going to basically look at a couple of different methods on how to wrangle, which is a very popular word in data science and data engineering and data analytics today. We like to use the word wrangle, like wrangling a pack of cats, a herd of cats. You're herding cats, okay? And a lot of times the data where it's collected may not be formatted. It may be in a format that is very difficult to use, so it has to be reformatted or reprojected so that it can be utilized. So we're just going to look at some very, very basic stuff. It's a taste. So one of the nice things about Python coding is that first of all, it's free, which is a very good thing. And then the second thing is that it's modular. So you can add or remove certain things to make it run faster, run more efficiently. And so we're going to look at some of the libraries that you're able to add on, which are features. So these are features that can be added on to the programming language to gain additional support. Pandas. This is a Python data analysis library. This is something that comes with the package. It is a very powerful, comes with powerful sets of tools for analyzing data, formatting data. There's another one that we use called GeoPandas. And GeoPandas add support for geographic data onto pandas objects, such as geoseries and geodata frame types. Now, I don't know about you, but my kindergarten, my daughter knows what data frames are because they're teaching that in kindergarten. Okay, that's how seriously data science, data analysis is going to be in the future for everybody. But what GeoPandas does, it takes not just a data frame or a series of data, it adds geographical data to those objects to those data frames, these databases, so that you can act on shapely geometry objects and perform geometric operations. Okay, it's very, very powerful. So let's start the exercise. And what we're going to do, we're going to review the intro briefly again, and we're going to take a look at the data sets. And then we're going to read through the code and review each step. And then as we perform those steps, we're going to discuss the output of them. It's going to be quite exciting. It's going to be quite exciting. So real quick here, this is our part. We're in the last week of the course, and we are looking at we're going to be doing two specific discussions, which I'm going to break these up into three different exercises. Geospatial discussion, and then we're going to be looking at the machine language discussion. Okay. So let's get on with the first one here. As an introduction, and we just covered this. This is how you start out the data sets. Okay, we're starting out with the data sets where we're importing this library. Remember GeoPandas. We're importing it as this alias, GPD. So you're not going to see this in the code beyond this line here. You're going to see this in the code. We're going to see the alias. And I'm not going to go into all the reasons for that. You need to take a Python course with me, or in some other department, or online, whatever, to go into those explanations. So we're going to import that. Notice this is running. And do realize it takes time. One of the things with coding, it takes time for notebooks to run. The input data is on this side here. Input data is on this side here. And the data set that we're looking at is this one here. There's a lot of data in this file, so we can have lots of different talks on this, about this. And go down, we're looking at by the way, whenever you see these here, this is a warning. It doesn't mean it's not working. It's just a warning telling you that the data set that's used is incompatible with the version that we're currently compiled. So we're using a different version, and it's going to be a little slow as a result of it. And we saw how slow it was. It took a while for that. But the next step is a read file, right? Remember that alias, GeoPandas read file, and it's reading this file right here, which is, see, Geospatial Learn course data, DEC lands. So inside here, I'm going in that folder. But DEC lands, and it's pulling up this shape file. So inside this folder, if it ever opened, but inside that, which is probably it's a shape file inside, but it's pulling up this shape file. And what we're going to do now is that it's going to view just the head. So whenever you see this term head, it's only looking at the first 5 rows of data. This is what you would do to see what kind of data set you're looking at, and always make sure to scroll to the right to see the full length of columns, the full row, the full set of columns that are in a data set, so you can see all of the information present. Object ID, category, unit, facility, class, UNP, description, region, county, URL of where the data is taken, the source who produced the data, information like that, acres, green space. Here's a shapefile area, okay, shape length. It's a polygon with coordinates, the geometry, okay? Very, very important. And we're looking here that we're looking at the class column. The first 5 rows corresponds to different forests. Okay. On to the next one. Now this here is saying, well, what type of data are we looking at? We are looking at a geoframe, a geodata frame. That's what it's telling us. So it's telling us what we're looking at, what type of, what the data frame is. Next one. This here is taking a part of the data, taking all of the rows, and only taking class, county, and geometry. Okay, and it's copying it to this variable. Okay, it's copying it to this. We're asking here, how many land types of each type out there? How many types of the land types are there? So it took a copy of the whole thing. Remember that data. It's placed here. And then we run this command. We run we perform this on us to determine how many counts of each class are there. And being blank, it's for all of them. We want to see how many are in the entire thing. There's wild forest, intensive use, primitive, wilderness, administrative, could be buildings, unclassified, historic areas, primitive bicycle corridors. When we say primitive, it's probably not paved, so it's a dirt path perhaps. Canoe areas, okay? Class, data type, integers. Not going to go into much more detail than that. Now, here, we're going to select those land types that fall under wild forest or wilderness categories. And we're going to select the data set for just those 2 columns, all of them. And we're going to then look at the headers, the first 5 lines. Bam. Wow, there's the type, county, and this is the geospatial information, those shape files. Now, the next one, we're going to now plot. We're going to plot that file. We're going to plot it. See, we're going to plot the whole thing. And this is a plot that shows where it's located. Now you say, well, what are all these numbers here? Well, these numbers are part of this data set here. Okay, those shapes. It's kind of hard to zoom in. You really would use another visualization tool to perhaps look at that with greater detail. But every geodata frame contains a special geometry column, and it contains all the geometric objects that are displayed when we call on the plot method. Okay, what we see right here. Next step is view the first 5 entries in that geo column. First 5 entries. Okay, it's geometry. Okay, it recognizes that it recognizes that it is a polygon. It's not a point. It's this point from that point from that point. It's a bunch of interconnected points. It's a row of points like this, and it recognizes that to be a polygon. It's not a line string. It's not a point. It's a polygon, and that's what's in this data frame. Okay. Next one. So here is we're going to generate a couple files. We're going to create points of interest, which we're going to be calling these campsites. We're going to be looking at foot trails, road trails. Okay, we're calling them trails. And then we're going to be looking at county boundaries. So polygons. So the campsites are point files. The trails are going to be line string files, right? And the county boundaries are going to be polygons. Okay, it created those. Stop running. It created those. Next, we're going to define a base map with those county boundaries. So we're taking counties, we're putting it in a figure, no color, using this type of formatting and this layer. Okay, we're telling it there are 3 layers, and then we're going to plot those three data sets that we called on and generated here. Okay, campsites, trails, and counties. Let's run that. Bam, there you go. Those may recognize this is a map of New York State. The light green are our wildland areas. The campsites are a maroon, this maroon reddish color. Those are campsites. And the trails are in black. Pretty cool, huh? Any questions? Take questions. I'll do my best to respond to them. So this is, once again, it's a good exercise. And we're using the Kaggle system, which I highly, highly recommend, the Kaggle system.